Well, good afternoon, everyone. Cynthia Tomain here with Interactive Brokers, and thank you for joining today's webinar being brought to you by our studio. We're very pleased to have Jonathan Regenstein, Director of Financial Services, with our studio to deliver today's session. So with that, let me pull up my information and we'll get underway here in just a quick second. Okay. Let me see. I had a quick introduction from Jonathan, but Jonathan, I'm going to ask that you deliver that intro. I think it's buried on my machine. So if you can give us a quick introduction, I'm actually going to pass you the controls as well so that we can go ahead and get underway here today. Well, Jonathan, thanks so much for joining and welcome.
All right, thank you, Cynthia. Hopefully everyone can see my screen now. And if you can't see my screen, I guess put it in the questions or the chat, but hopefully everyone can see it now. So thank you, Cynthia. And yes, okay, great, okay. All right, well, thank you very much. And oh wait, gotten questions here. Okay, all right. So as Cynthia said, I'm Jonathan Regenstein. I'm the Director of Financial Services here at our studio. And before I came to our studio, I spent some time working in finance at JP Morgan, did some graduate work in political economy at Emory University. And then from there, I matriculated over to our studio. And in my role as the Director of Financial Services, I work with quant teams at a lot of different types of institutions, commercial banks, central banks, investment funds, hedge funds, really anyone in the financial services industry. So it's a really fascinating place to be. And thanks to everyone for coming out today on a Friday. You never know how many people are going to turn up to spend their Friday talking about data science and code. I know I like to do that, but I don't know how many other people do. So thank you all very much for coming out. And with that, let's get started. We're going to be talking about data science and R for investors. And what we're looking at on the screen here is some R code. And just by way of brief introduction to what R is, it is a statistical programming language. It was created about 25 years ago in New Zealand. It derived from the S programming language, which had derived from the C programming language. And I like to say that R is by data scientists for data scientists, meaning that R is not a general purpose programming language that a software engineer would want to take and build the internet on top of, but it is a programming language that quants and coders want to use to do their statistics. So it has all the things that we need to do our data science and our quant analysis, but it doesn't have a lot of the abstract knowledge that comes along with the general programming language. So for someone like myself, who is definitely not a computer scientist, R is a very friendly language, and it kind of has all the tools that I need. So R consists of base R, that thing that was created about 25 years ago, and the package ecosystem, which is up to about 17,000 packages now. So one of the beautiful things about R is that really anyone can build a package and contribute it to R and make it part of the programming language. There's a central repository for all of those packages called CRAN, where you can submit a package, and if it goes through their checks, they'll make it available to the public, and anyone can download it. But you don't have to submit to CRAN. You can just put it on GitHub and let everyone know it's out there, or you can keep it private, which is what substantially all of our financial services customers do. They build their own private packages, so they're almost building their own little R ecosystem with functions and visualization tools. But the great thing about the package system is that as more people build packages, and then more people build packages on top of those, and et cetera, the power of R is just growing exponentially, really, as packages get built on top of each other. So it's been a really exciting time to be an R coder right now. So I work for a company called RStudio, and we build tooling for the R ecosystem. And a big part of that tooling is what we're looking at here on the screen, which is the RStudio IDE. IDE stands for Integrated Development Environment, which is really just a way of saying that this is where our coders come to write their code, load their data, build their models, run their data visualizations. So this is RStudio is kind of where our coders come to code. It's free and open source. You can go download RStudio, and in fact, you can go download everything we're going to be doing today for free tonight and reproduce all the work that we're going to be doing. A really important piece of the R toolchain that we build at RStudio is something called Shiny, and Shiny is actually an R package. It's also the name of a product that we sell, but at its core, it's really a package that turns your R code into interactive web applications. I can just show you a quick example of what that means, because it's kind of hard to visualize, but this is a Shiny application, right? We're going to be building a lot of the code that runs this strategy and calculates these statistics and builds this chart. But while we're running it in the IDE, we have to kind of go in there and change the code. With Shiny, you don't really need to be an R coder, obviously. You can just choose a different asset. You could choose a different period to backtest and click submit. And just like any other interactive dashboard that we're used to, it's going to take that different data and run it through our calculation engine and show us results, right? So all the code that was written for this is here in R, but what comes out the other side is a nice HTML and JavaScript-based visualization dashboard. I myself can't write a line of HTML or JavaScript, and that's kind of the beautiful part of Shiny, and one of the reasons it's becoming so popular is that it allows us to just be data scientists who use R for quantitative analysis, and then Shiny turns us all into having the ability to build interactive web-based dashboards. We're gonna go through a little bit more how we actually built these strategies and ran these calculations, but really it was Shiny that turned it into this dashboard. So that's a very quick look at the R tool chain: base R plus packages, plus RStudio, where people come to write their code, plus Shiny, where you can come share your results with other people. So that dashboard, obviously, you could send that to anyone in the world, and they probably wouldn't know or care that it was R that was running underneath it. Or you could just use it yourself if you wanted to maybe explore different parameters for any of the models that you've built. All right. Well, I mentioned the package ecosystem. Let's talk about some of the packages we're going to use today, because we're going to go through a real example. We're going to code up the dashboard that we just saw there in the Shiny app, because I think that the best way to learn about R is to really just dive into a project and work with it, which is how I learned R myself. But the packages we're going to be using, this is a very, very prominent actually collection of packages called the Tidyverse. We build and maintain the Tidyverse here at RStudio, which can get a little bit confusing for people because we have a team of people here headed by our chief data scientist, Hadley Wickham, that we pay to maintain the Tidyverse, which is a bunch of free packages. So sometimes people get confused. How are we paying a team of engineers to maintain free packages? It's just something we do to contribute back to the R ecosystem. And this collection of packages is the most popular set of packages that are downloaded from that central repository of packages. TidyQuant is more specific to the financial world. It's trying to take some of these Tidyverse concepts and make them applicable to financial data. TimeTK and TibbleTime are both for working with time series. HighCharter, this is a really interesting example of an R package and the power of the package ecosystem. So there's a JavaScript library out there called HighCharts. They also make HighStocks. It's a really powerful JavaScript visualization tool. And some R coder came along and wrote a package called HighCharter, which allows us to use those JavaScript-based visualizations without actually having to learn any JavaScript. And there are tons and tons of examples of packages like this that are R hooks into interesting visualization libraries that allow us to use 95% of the functionality in those JavaScript libraries without actually having to become JavaScript coders. So R just opens up a really big universe to us. Broom is for tidying up data. Performance analytics is a package that's specific to the financial world. It calculates some analytical things having to do with the performance of assets. We're going to go through one of the functions from this package, but there are 50, 60 really useful out-of-the-box functions here that are really, really good for exploring your data, pulling in some quick summary stats. We'll look at a couple of examples, but this is a great package to start with when you want to do any sort of financial analysis. There are tons and tons of packages purpose-built for finance. And you could Google R packages for finance, but this is a web link that has them all listed. I don't know how many there are now, but there are several hundred packages. Some of them are very specific. There's an entire package called Yield Curve, for example, which is just for calculating yield curves. And then some are more general. There's one out there called Portfolio Analytics, which is for running mean variance and other constrained optimizations on portfolios. So there's all variety, all flavors of packages out there, and it's definitely worth having a look there, especially if you're starting a new project. There might be a package out there that's already solved 75% of it for you. And you can concentrate on the 25%. All right, so what are we going to be doing today? We're going to do a real life project here. It's a well-known trend strategy where we're gonna build a strategy that buys the S&P 500 if the 50-day moving average is above the 200-day moving average, so-called golden cross, but sells the S&P 500 if the 50-day moving average is below the 200-day moving average. Okay, well-known strategy, nothing new there. We're just going to go through how to code it up. We're going to visualize the results. We're going to pull out some descriptive statistics just to get a flavor for what we've done. We're going to compare it to a buy and hold strategy. And then after that, we're going to start adding some secondary logic. So we're going to complicate the trading. You can think of it as an algorithm. We're just going to add more signals to it. Our secondary logic will basically be looking at a z-score for how far above or below the actual price of the S&P has moved from its rolling mean. And we'll visualize that strategy. And then I'll just quickly show how that turns into a shiny dashboard. Before we jump into that, though, I'll just say a quick word about data science in general, because it's something that's kind of important to have squared away. So I've pulled up what we kind of think of as the data science paradigm here at RStudio, and this came about from a lot of work that our chief data scientist, Hadley Wickham, has done. This is kind of how we think about the world of data science and how a typical project flows. And I like to pull this up just so that we can have in our minds how the project we're going to be doing today would map onto the kind of general data science paradigm. So we start with importing data, which can be a kind of mundane, sometimes frustrating step in the process, but it is crucially important when we think about reproducibility to really spend a lot of time on thinking about how to make the import step as clear and transparent as possible, whether that be for our colleagues who might need to reproduce our work. And at RStudio, we like to somewhat jokingly say, don't forget about one of your most important collaborators, which is your future self. Because in 12 months, if you open up a notebook, you'll think to yourself, where did this data come from? Why did I pull it in from an Excel spreadsheet that I can't seem to find anymore? So it's not just other people who are collaborators. If we can make it obvious to our future self in 12 months, that will be very, very helpful to us, and it's a big step towards reproducibility. So we're going to be pulling in public data today from Yahoo Finance, so the import of the data won't be difficult. But in industry, you will almost always be pulling in something from an Excel spreadsheet or a CSV or an internal database, and increasingly via API. So documenting how that happened is really important, and it's not a lot of fun, but it's really important. Then we get to this tidy and transform step. This is often referred to as data wrangling, getting our data in shape for what we want to be doing with it. And as we're going through the steps today, hopefully I can convince you that this wrangling piece, getting our data in shape, if done right, really makes the modeling piece and visualization piece relatively painless. So we're going to be trying to implement some trading logic, and if our data is in the right shape, we're going to be able to implement that logic in a pretty intuitive way. And then visualizing and modeling, there's this virtuous circle where we visualize, we look at our data, we model it, we try to extract some interesting trends or thoughts or relationships in our data. Maybe we try to do some predictions. We're not going to do that today. It's not really appropriate for this data set, but these things all kind of work in a virtuous circle. And then not pictured is the shiny piece where we actually communicate this to somebody else. Again, that could be ourselves, could be other stakeholders who really don't want to see our code. They just want to see a final result. All right, so that's kind of a data science paradigm. I like to pull that up just to orient what we're going to be doing, because we're going to be going through quite a bit of code here, which I hope everyone was expecting and up for. I've always found it unusual to give a presentation about writing R code and then put it all up into a PowerPoint where there is no code and there is no data. I've always thought if we're going to talk about R code, let's just go through the R code. So I hope everyone was ready for this on a Friday. Okay. So as we saw in that PNG, our first step is to import the data, and we're trying to work with the strategy for looking at the daily moving averages of the S&P 500. So we want to get data on the S&P 500. We're going to use treasury bills as kind of a risk-free asset, so we're going to pull down data on those as well. We're going to use a function called TQ_get, which stands for tidyquant_get. It's from the tidyquant package. It's very common for people to append some sort of letters to the functions in their packages so that people can remember them and associate with them, right? So this is from the tidyquant package, and they could have called this function something like stock market data get, right? Something generic, but that wouldn't have associated it with tidyquant package. So oftentimes people will append a couple of letters so that people can remember where these functions are coming from. Well, we need to pass it in tickers, which we're going to do right here. These are the tickers for the S&P 500 and Treasury rate. This C concatenates these things into a vector. So R is a vectorized language, similar to how you can maybe think of like a column of a spreadsheet as a vector. R is a vectorized language. You can just pass it in vectors. We're going to call our vector symbols. We're going to pass it to TUGet, and we're going to say we want prices starting in 1990. When we run this code, it's going to reach out to Yahoo Finance, grab this data, and bring in the date, the open, the high, the low, the close, volume, the adjusted prices, quite a bit of data. And this isn't unusual data, so we probably didn't really need to kind of peek at it here, but after any data import step, it's just a best practice to almost force yourself to look at it and make sure it looks about how we were expecting it to look. Especially if you start thinking about alternative data sets and maybe assets that are priced from different countries that are a little less transparent than what we grab from Yahoo Finance. It's just a best practice to have a step where you just look at the data before we start doing anything to it. I'm not gonna run this code, but if this data had been sitting in a CSV file or an Excel spreadsheet, R has these nice functions for grabbing them: read_Excel, read_CSV, really convenient ways to go grab your data from Excel files. There's also this button up at the top here, it says import data set. I'll open it up so people can see. And it's going to ask you, what kind of data are you importing? Is it an Excel file? Is it from SAS, God forbid? If it's a CSV file, read R. Tell me where this Excel file lives. I would give it the path to the data, and I could import it right there. We're not going to do that because I want this to be reproducible from anyone who just kind of pulls this down, and don't really have a way to share the Excel spreadsheets. But if anyone has questions. All right, so we've grabbed our data in its raw format from Yahoo Finance, and I always like to, in addition to the raw data, just put up a quick visualization, right? And this is a good example of using HighCharter, which is again a JavaScript-based library with R hooks into it. And since it's JavaScript-based, we can kind of scroll over here and interact with it a little bit. And again, nothing surprising here. It's the S&P 500. We probably all know what this looks like. But if this weren't the S&P 500, if it were some alternative data or I don't know, high frequency data on some time period that we had specified, we'd want to take a look at this. There could be some huge gap that we weren't expecting, or some huge drop up and down, or maybe just something to indicate there's a problem with our data fidelity. We want to discover that now, before we start doing anything to this. Because once we start wrangling this and tidying it, once we do that, if we discover any errors, we won't know if it was because of how we were wrangling it or if it was because of how the data provider provided it to us. And it's very hard to unwind that, and it's very frustrating to unwind that as well. But this looks pretty good to me. Not surprisingly, we just grabbed this data from Yahoo Finance. Okay. Well, we also want to calculate the returns of this data, and you can think of this as a very simple but important transformation of our data. We were given prices. We want to transform it into returns. And it's going to allow us to look at a really, really important function called mutate. And what mutate does is it allows us to add a column to our original data. And we'll see how we're going to use it extensively throughout this presentation. And here we're going to add a column that's the returns of our assets. So we're going to call mutate and say we want a new column called S&P 500 returns, which is the log of the price today minus the log of the price yesterday. Okay, we're just going to returns there. Daily treasuries have a little bit more of a complex way of calculating their daily returns because they're not really just quoted as prices. And I kind of did that on purpose to show that with mutates, you can put whatever equation you want on the other side to create a new column. So writing this code is going to give us two new columns, S&P 500 returns and daily trez. And if we peek at our new asset here, you can see we have our date, our original data that we brought in, S&P 500 and trez, and then we have two new columns, S&P 500 returns and daily trez. So we've transformed our data. All right, so we're off the raw data, we're transforming it, and we're working with our own interpretation of this data now. So let's take a look at some stats that can come out really, really quickly from this data. There's a great function in the performance analytics package called table.stats. It's really nice for just peeking at the data and seeing if everything looks how we want it to look once we've taken this to returns. So I'm going to take my returns object. I'm going to say let's peek at the S&P 500 returns because the treasury returns aren't that interesting to me, and let's apply the table stats function to it. And not a whole lot of actionable stuff comes out of this, but some interesting things just to think about. So it tells us the number of observations, about 7,200. So about 252 trading days a year. We have about 28. We went back to 1990, so we have 28 years of data. There's only one NA. This is always an important column to look at. That one NA is because we calculated returns. So the first observation has no return. It was just a price, so we put that to NA. If this said 100, that would mean we had a lot of missing data, and we would really want to go examine that and figure out where it is and if we want to delete them or impute values for them. But it's always good to glance at the NAs. Variance, standard deviation, skewness, we have kurtosis, just things to kind of maybe get us thinking about how the returns of this data are distributed or dispersed. We're not going to run these, but there's a lot of good functions, like I said, in performance analytics. There's table.capm if you want to really quickly run a simple CAPM analysis. You obviously have to provide a market return there to regress against. Drawdowns, you can look at the drawdowns of your assets, downside risk, there's semi-deviation. There are a lot of great functions in performance analytics. So it's definitely worth exploring that package. All right, let's move on a little bit here, and let's put up another visualization. All right, so here's a scatter of the S&P 500 daily returns since 1990. Nothing too surprising here. It's a data set we're pretty familiar with. This was created using a package called ggplot2. This is part of the Tidyverse. It's one of the packages that we build at RStudio. For building static visualizations, this is by far the most popular data visualization tool in our world. So I wanted to make sure we had at least one example of it up here. It's very flexible. You can see I'm calling geom point here. If we change that to something like geom line, this would become a line, which would be very, very, well, a very scraggly line. But if you want to create a histogram, you can go to geom histogram, which would require a little bit of a different grammar. But ggplot is very flexible, and it's a great way to just explore our data, visualize things a little bit. I mean, this is just a quick and dirty visualization, but you can see, like, well, we can see that the most kind of a risky or the most dispersed period of time was right around late 2008. Kind of confirms what we were thinking. If this didn't look this way, if this dispersion period for some reason was out here in 2017, that would probably be a flag that something weird is going on. This has been a not very volatile period the last couple of years. So if this dispersion was showing up around 2017, that would be something worth exploring. We want to know why. All right. We've written quite a bit of code so far. We've gone through things kind of quickly. We haven't actually gotten to our strategy at all yet. We haven't even calculated moving averages. But I do just like to pause really quickly. Why we're spending so much time today exploring this data? And the reason for that is that at least in my experience and from what other people have told me, the highest performing quant teams that we see spend a substantial amount of their time just exploring data. Before they even start writing their algorithms and before they get to all the stuff we're hearing about in the news where they're fitting machine learning models, trying to pass stuff through neural networks, they just visualize and look at their data and they're looking for patterns or interesting relationships. So exploring data, it takes up a huge amount of time. Like we're trying to find insights in data that everybody else has missed. I mean, that's what we're looking for, whether it be for generating better returns or just managing our risk better or looking for assets that we didn't think were correlated, but they are. Spending a lot of time exploring data will never serve us wrong. So plug for exploring data. Okay. Well, that's good. We've explored our data, but let's get into what we actually wanted to be doing, which is comparing moving averages. Well, if we want to compare our moving averages, the first thing we have to do is calculate our moving averages. And to do that, we're going to want a function, and R has a package called TibbleTime with a very, very useful function in it called Rollify. I'm highlighting here. And what Rollify does is it takes other functions and makes them rolling. So in this case, there's a function called mean, which is part of base R. It was part of the things that the creators of R thought every data scientist would need, a function called mean. And Rollify says, great, give me that function, tell me the window you want to roll it on, and I'll turn mean into a rolling function. So we're going to turn it into a rolling function called rollMean50, and we're going to do it again and make a function called rollMean200. So that'll give us a way to calculate the rolling 50-day mean and the rolling 200-day mean. And just like we did above when we wanted to just calculate returns, we use mutate to add another column. In this case, we're going to add a column that's the rolling mean. The mutate is a very, very important part of almost every workflow that I see and that I'm a part of. Mutate really helps us turn our data from raw data into what we want to be working with, and eventually passing into algorithms, frankly. All right, so we have mutate. We start off with our raw prices data, and then we tell mutate to apply or to create a new column called SMA 200, where we apply our rolling 200-day mean function to the S&P 500, and another column called SMA underscore 50, where we apply our rolling 50-day mean function. And what's going to result from that is a new data structure with date as we had before, S&P 500 as we had before, and treasuries as we had before. And now we have the rolling 200-day and the rolling 50-day means of the S&P 500. So this is kind of the core of what we were hoping to do with our strategy. We want to add some data to our data set, which in this case is these rolling means, and we're going to try to look for a little trading signal, right? That the creators of this trend strategy have hypothesized as a strong signal, right? But really the core of what we're doing is calculating these things and then comparing them to each other. And as I said, when we think about tidying data, wrangling data, and transforming data, which is the step that we had in here. Once we've kind of made these calculations, comparing these two is not a computationally difficult task. We're just going to see if one is greater than the other. And we'll go through how to do that in a second, but as long as we're keeping our data organized and tidy, building these kind of signals, we can think of them as algorithms, we can just think of them as if-else statements, it is going to be a lot easier on us because we have our data organized. All right, so let's implement this system or this trend strategy, whatever we want to call it. And just a quick reminder of our logic: it was if the 50-day MA is above the 200-day MA by, else we're going to go to the risk-free return, which is treasuries, or we could just go to zero if we preferred for simplicity. We're not taking into account any taxes or trading costs, nothing like that. This is a toy model. Hopefully everybody is on board with that. This is not a real fully implemented tested algorithm, but we are working with real data, and the code definitely is something that could be repurposed into something more complex if you wanted to use it as a template. All right, so just to remind ourselves, what do we need? Well, if we're going to compare a 50-day moving average to a 200-day moving average, we need to calculate those things. We did that above. We need if-else logic. We need to tell the computer, tell R, if the 50-day is above the 200-day, do something. We want to create a buy and a sell signal, right? If we want to calculate the returns of the strategy, we also need the returns that we calculated above. We need to apply this signal to those returns. So before we look at it in the code flow, setting up the signal is not difficult once we have the data calculated. So we have SMA 50, that's what we calculated above the 50-day moving average. We have SMA 200, that's the 200-day moving average. We're going to create a new column called signal that says, if the 50 is above the 200, give me a 1, else give me a 0. And that's a very simple way to kind of implement this strategy. And then we're going to add in our returns by saying, if that signal is a 1, by the S&P 500. Take the signal times the daily returns of the S&P 500. So again, as long as our data is organized and kind of coherent, it's going to be a pretty simple coding exercise to add this to our data. So the first, 8 to 10 lines, this is what we've already done. We've calculated our returns above for the S&P and the daily treasury rate. Again, we're using mutate. We've calculated our rolling means. We did that above. And now we're going to add a signal, a new column called signal, right? Which is going to be a 0 if the 50-day moving average is below the 200-day moving average. If we wanted to say, well, just show me when they're 1, like show me when this thing's actually going to get turned on, we could filter it and say, look at the new signal column and just show me when it's equal to 1, right? And this is just going to pull out all the dates where it's equal to 1. And you can imagine that then we could visualize that and say, well, what's the percentage where the signal is 1 and what's the percentage where the signal is 0? We could go off and do a lot of interesting things with this. We're gonna kind of plow ahead, but that's definitely an area that's ripe for some visualization, so we can get a sense for how frequently our signals turn on versus off. Okay, so we have our signal. It's a bunch of zeros and ones, which is always convenient, makes it easy to work with mathematically. And we have our returns, our S&P 500 returns and our Treasury returns. And what this trend says is, if this is a 1 by the S&P, we're just going to assume we get that daily return. I'm going to lag the signal. So I'm going to say, look, if yesterday's signal was 1 by the S&P today, that makes more intuitive sense to me. But you might have a signal that's different that says, no, if today's signal is 1 by the S&P today. That would take a little timing coordination. For simplicity, I think it's easier to think about if yesterday's signal was 1, but there's probably good reasons not to oversimplify it. But for today's purposes, we can oversimplify. So now we have a new column here called trend returns, which is here on the end, the very end column right here. That's showing us the returns of our strategy, frankly, of our strategy that says when the 50-day moving average is above the 200-day moving average, buy, else don't buy and just take the risk-free rate. So we've kind of calculated the returns on that strategy. We have a new column holding it called trend returns. It's not really that interesting in isolation, though, because we have no idea how it would compare to just a buy and hold strategy. So we can create a buy and hold strategy that says just always invest 90% in the S&P 500 and always go 10% in the risk-free rate. You could create a vast number of iterations on this: conservative buy hold, aggressive buy hold, where you're giving different allocations to different assets. So this whole thing can be complicated in a lot of different ways. We're going to take the simplest possible way of looking at it. We have a column now called trend returns, another one called buy hold returns, and we can put these side by side with each other and see how they look. Now, for me, and this is my own personal preference. Other people might have a different way of visualizing things. I like to take these returns and turn them into how a dollar would have grown. I think it's a more intuitive way to look at things. Probably for people like yourselves who are professional traders or people who do a lot of trading, you might not need to do that. But I find that turning them into a dollar growth just makes it a little bit more digestible for people. And it's a good chance to look at another function in the R world. And that function is called accumulate. And you can think of this as like a cumulative product or a cumulative sum. But if we want to know how, say, a dollar would have grown in our strategies, we can again use mutate. So hopefully you're getting tired of hearing about mutate, and that was by design. So hopefully you'll leave this webinar and think, oh, why was he talking about mutate so much? It's so obvious how to use it. And that would be great, because I hope that mutate starts to really become a part of how you're working with R, because it's a very, very useful function for adding columns to our tables or our data frames. In this case, we want to know about the growth in that trend strategy. So we can say, okay, we'll accumulate all those returns, add 1 to them, because we're investing $1. So accumulate 1 plus the returns, and then use a cumulative product. We could put something else in here, like an addition sign. It will just give us a cumulative addition, which wouldn't have much meaning here. We'll do the same thing with buy hold. We'll accumulate the buy hold returns too. So now we have at least how a dollar would have grown, a little bit more meaningful, right? We can see that when we go to the very end of the strategy here, September of 2018, you can see that the trend growth did pretty well here. Obviously, we already knew the future, so we were able to create a strategy that would do very well. We went through a couple of rough market periods. Let's visualize these results again. Kind of going back to here, we've done a lot of toggling between visualizing and transforming. Not really a lot of modeling, unless you think of taking those moving day averages as modeling, but we're just kind of going around the circle until we find something meaningful, something that we're ready to communicate to the outside world, I suppose. And here's what these two strategies look like. Actually, I did find one thing I thought was kind of interesting, which is that, I mean, from December 7th, 2017 to what is that? June 24, 2009. I mean, this is just flat for our trend strategy. it just divested and it just stayed flat. And I mean, we all know why. And obviously, with hindsight, it's easy to build these that take account of it. But even with hindsight, I thought it was interesting that it was totally flat during this time, and the buy hold strategy just crashes. And that's really, if you want to know what differentiates these two strategies, it's pretty clear that it's this time period, which is why the trend growth is way outperforming it over this period, this strategy, this time period right here. I actually thought that was kind of interesting, even though it's exactly what we would have expected. Sometimes it's nice to see exactly what we were expecting. And to me, it's another good just way to look at, well, why are these JavaScript visualizations so useful? I mean, we could have just looked at it like this, but it's nice to be able to go hover and see the exact dates and the exact dollar growth that we're seeing throughout these dates. All right, well, if you think back to not that long ago when we used table stats to calculate some of those just quick statistics on the returns of the S&P 500, well, we can use that same function to get some quick statistics on our two strategies here, right? We have our trend returns, we have our buy and hold returns. We can fire up table stats. It's gonna give us back those summary statistics again. So again, I like to just peek at the observations. It's good that they're equal. Neither one of them threw some weird error or something or had some unexpected behavior. NA's 0, good. I'm glad those line up. Kurtosis, about equal. Wasn't really expecting that, but these strategies aren't far off from each other. The skewness of our trend returns is negative, and it's much more negative, but it's not a big skew. Anyway, there's some stuff to dig into here. I like to just call up table stats and just peek at it. If nothing jumps out at us, that's okay. Table stats is just a good way to get a quick feel. Okay. All right. So that's kind of step one of our strategy, right? 50-day moving average versus 200-day moving average. I want to show really quickly how to implement another layer of logic on top of that, because that tends to be how strategies or risk management strategies or any algorithms work, is we're layering if-else statements on top of each other. So we need to be able to have more than one. Okay, so let's add another one. Let's say that we're kind of happy with those preliminary results of that simple golden cross, death cross strategy. We think it's interesting. Someone says, I want to add a more complicated signal. So the first thing I want to do is I want to calculate a z-score. And the person says, what's a z-score? And they say, well, tell me how far away the price of the S&P 500 is from its 200-day moving average, and that's the spread. And then I want to divide that by the number of standard deviations and see how, basically turn it into a z-score of its distance from its mean. And we're going to use that as a signal. Okay, we're gonna add it to our other signal. This is going to be a two-signal strategy. Well, how do we do that? It's a very similar flow to what we had before. So this is not changing anything. This is our trend signal. And then we come in and we say, well, you said you wanted a spread of how far away the S&P 500 is from its 200-day moving average. And we want to normalize that, turn it into some sort of a z-score, where we say, okay, well, give me the z-spread minus the mean of the z-spread divided by the standard deviation of the mean spread. We're just normalizing it. We can put any logic we want in here, which is another one of the really beautiful things about Mutate. And then we're going to create another signal. This is actually kind of a complicated signal, because I'm going to say, look at the z-score 1 time period ago, 2 time periods ago, and 3 time periods ago. So this is a signal that has its own nesting structure, because I want to capture all 3 of those. It's not enough for me just to look at one z-score. Maybe I think that's too noisy. I want to look at 3 z-scores. And lag is saying go back 3 times. Lag 1 is saying go back 1 time period. Lag 2 is saying go back 2, and lag 3 is saying go back 3. So I'm layering these on top of each other, and I'm turning it into another signal. And once we have that, we implement it in the exact same way as we did before. We're going to use if-else. Still going to use our trend signal. So if that equals 1, okay, we want to make that a positive signal. And then we just, it's a pretty intuitive way of adding a signal. We use and. This is the little and operator. If you hold down Shift, when is it, shift 7, you'll get the AND operator. So we can keep adding these in here. In this case, we're going to say if the trend signal is 1 and the Z signal is 1 by the S&P 500. I want to compare that to my trend returns where I just have if the trend signal is 1. And again, we're going to compare it to our buy and hold. So we'll look at the results of this and the visualization. But the more general point is that we're kind of building this up iteratively. I mean, we started with our raw price data, and we were very explicit about where it came from, and we investigated it, we visualized it, we were satisfied that everything looked good, and we've just been adding essentially columns with mutate, and then we're adding more signals, and we're just building this up and up and up, and we're almost telling a story with this data from the beginning, which is the import, to the end, which will be the Shiny app, and our goal is to make this reproducible in 2 ways, really. The first way to make it reproducible is that someone should be able to take this code and rerun it and get the exact same result. All right, so that's one layer of reproducibility. Typically, when people talk about reproducibility, that's the layer they're talking about, the ability to rerun the code. I like to also focus on another layer of reproducibility, which is, could another human understand what happened here? It's a really important thing, especially if we're going to start taking this data to more complex modeling structures, any sort of, say, machine learning, which is all the rage right now. But we still need to be able to explain how our data got from our raw import to being passed into this machine learning box. And I mean, there's actually some pretty good tools out there right now for opening up the box. So I think it's not a good excuse to say that machine learning is a black box anymore. So we still need to be able to tell that story with increasing levels of complexity. All right, so back to what we were doing. We now have 3 returns that we've calculated. One that's trading off of 2 signals, our trend and our Z-score, trend returns, that's trading off of just our trend signal, and buy hold returns. And then we're going to turn each of those into a growth of $1, same as we did before with the accumulate function. And what emerges is very similar to what we saw before. This has all of our data in it. It has the dates, it has our trend signal, it has our Z signal, it has our buy hold returns, our trend returns. Anyway, we can kind of scroll through here in all of our growth. So it's all self-contained, it's all here. We can just kind of peek at it and see if it looks how we're expecting it to look. But of course, we also want to ultimately visualize this, which is what we see here. So again, it's kind of interesting to just take a look at this. I mean, they're all tightly bunched here through the 90s, not really a lot of separation, and then buy hold just takes off on the internet bubble. These guys kind of lag it, and then there's another just totally flat period here. Totally flat from about December 2000 to about March of 2003. So over 2 years, another flat period, and I mean, same for our trend plus Z-score, also flat, where we see buy hold just kind of plummeting down here and then coming back. So I think there's some interesting patterns to explore here, despite the fact that these are well-known data sets. We haven't done anything terribly complex to them, but as I said in the beginning, it's never a waste of time to explore data and explore trends. And just to bring it all back to the table stats function, we can call table stats on all 3 of these strategies and just again kind of make sure everything looks the way we're thinking. One thing that is really weird is that there's our trend Z. Oh, that's why. Because this is calling trend Z growth. I was trying to figure out why. So when I was putting this together just a few minutes ago, I noticed that trend Z is showing this huge variance and this outsized standard deviation, obviously, as a result of the large variance. And I really couldn't figure out why. Now that we're looking at it, I see that I passed in the growth, which is not what I wanted to do. I wanted this to be returns. So I'll try it again. Always dangerous on a live webinar, but okay, that looks a little bit more reasonable. Trend Z should have a lower variance than trend returns. Should have a lower standard deviation as well, obviously, and lower skewness although they're about equal. But in any event, okay, well, there you go. Debugging on the fly. When you mistype, when you put your growth of $1 into the table stats, that's what happens. Okay. From there, we would want to wrap this to that Shiny application. And we only have a few minutes left, so I'll just call it up really quickly so that people can see it. I mean, Shiny is a fascinating and fun part of the R ecosystem, and it's becoming extremely important. I would say it's driving a lot of the growth of R because it's so quick to get up and running with taking that work that we just did and putting it into a Shiny app. So there's really kind of two main functions for a Shiny app like this. Right. I mean, we could say, well, let's just explore. I'm going to go with SPY instead of the GSPC. That they're virtually the same. So if you think back to the IDE, the way we did this was we pulled in data for 1990 to present day. Maybe we just want to explore different time periods, right? And the Shiny app gives us a good chance to do that, right? We could say, okay, well, take us back. I don't know. Doesn't matter. January. And this we could say, take us back to 1999. That's really going to change things. So we can explore different time periods. We can pass in different assets. This is a very simple example. We could change the way our Z-score is calculated, right? We could say, well, I want a Z-score that's calculated in a different way. Really what's happening under the hood here is Shiny is running our R code, all right? This is where we ask for these inputs from our users, but other than that, the code's going to look very similar. We have our rolling means, 50 and 200. We have our TQ get. It should all look very, very familiar from what we just coded in the IDE. And the reason it should look familiar is that I pretty much just copy and pasted it over here, which is really the powerful and wonderful thing about Shiny is that all that work that we just condensed down into about 45 minutes, but it took a lot longer than that. But now you can almost think of it as scalable in the sense that, I mean, I can scale this to any asset that's available on Yahoo Finance. We can pull in, we can pop in here. We can explore different time periods. We could also send a link to this Shiny app to somebody who doesn't know or care about R. They just said, hey, go explore this result for us, right? So there's a lot of different ways you could kind of host and distribute these. There's shinyapps.io, which is you can host them on our cloud. Most of our big customers use RStudio Connect, where they just stand up their own server internally and host these because they're not sharing them with the outside world. They're just sharing them with their internal team. But really, Shiny is just becoming a very powerful way to share your work and your visualizations. Here's a quick bootstrap of the distribution of the returns for I think this was for the Trend Z. We didn't cover that, but the point is you can put a lot of different visualizations in here. All right, we have about 6 minutes left, and I'm gonna go ahead and pause and see if there are any questions. We just covered a lot of territory, so thank you for sticking with me. As Cynthia said, I believe she is going to be sending out the recording to this and a link to where I've posted all of the code for this. So please don't feel like you need to grab the code from off of here. You'll be able to take that code from that website and rerun this in RStudio in whatever pieces that you feel fit. I'm gonna go ahead and take some questions now, and I'll just kind of read off the questions. Okay, so number one was, is this code available on GitHub or somewhere else? It's available up on a website. I can put it up on GitHub as well. Can this be hooked up to intraday data at IB? The answer is yes, it can be. I didn't show how to do that because it's a little bit, it takes going through some hoops. You need to enter in your passwords and your credentials. So this can definitely be hooked up to Interactive Brokers data. They have a whole tutorial, and there's an R package that helps you get all that set up. So I would definitely take a look at their university where they have some cool stuff for how to integrate IB data with R. There's a question, where do we get this data? The data that we're using today came from Yahoo Finance. how can we utilize our coding to day trading levels? So that's really not just a matter of our coding. That's just a matter of getting intraday data, right? So if you want to apply this code to day trading levels, you need the intraday data. It's not really a matter of the code. The code is going to take the data, it's going to analyze it in the way that you want to. All right. There's a question: will the recording be available? Yes, the recording will be available. And question: what tool to open up the ML black box? There's a lot that are coming out right now. The one that I prefer is called LIME, which stands for Locally Interpretable Model Agnostic. Can't remember the last one, explainer or something like that. But if you just Google LIME, L-I-M-E, it goes through how to open up the black box of an ML algorithm. And what it really does is it finds some local pieces of your data, and it uses however many permutations you tell it to use to try to figure out what that ML algorithm was doing in that local area. Globally, of course, it's fitting a non-linear model. It's very hard to kind of white box that, but we can white box local areas of the ML black box. So LIME is a good one. Dalex is another one that's becoming pretty popular. I don't currently have those posted as part of the code for this, but I will go add a section on interesting packages for machine learning. I'll include one on there called the forecast package, which is not a machine learning package, but it's a really useful package just for forecasting time series. It doesn't have a ton of applicability to stock prices because those are hard to forecast, of course, but for kind of out of the box forecasting tools, that package is very powerful, and it feeds in really well to actually HiCharter and Shiny data visualizations. All right. So question about alternative data. So if alternative data is something people are interested in, I just found out about this site called alternativedata.org. A bunch of quants up in New York put it together, and it's almost like Google for alternative data. They list all these cool alternative data sites. They also have a really good job listing board there for people who want to go be quant. Like tons of hedge funds and investment banks looking for coders. So alternativedata.org is a really good place to look at. And one more here. Can you use Mutate to add other data sets? Yeah, so I think the question here is, what if I wanted to add a column to my data that wasn't like a function of the other data, right? Because all we did here was we were adding columns that were the mean, the rolling mean, and returns. But we could just add a column called like inflation rate, and we would pull down the inflation rate, whatever, for every day in our data set, and we could add that. So we can add, I guess we can think of it as external sources of data to this as well with the mutate function. All right. Well, thanks a lot, guys. We are to 1 o'clock, and I don't want to hold anyone up on a Friday. So as we said in the beginning, the recording will be going out, and you'll have access to all this code, so you can get coding. Thanks very much for joining, and have a great weekend.
Well, Jonathan, thank you so much. Excellent information here today, and I do appreciate you sharing it with us. Also want to let everyone know that we have been recording today's event, and I'll be sending out a direct link to today's recorded playback soon after the session ends. So if you do want to come back and review the concepts, simply watch your email later on today. And as Jonathan mentioned, he's also provided us with a link to the code, and that will be included in those follow-up messages. We'll also be adding, for anyone who's listening to this via recording, we'll add that information on the Interactive Broker website. Underneath the education menu, you'll find a webinars link where you can locate today's presentation. So with that, I want to thank all of you too for for joining us here this afternoon. Have a great rest of your day, everyone, and thanks so much. You can exit using the X in the upper right-hand corner. Great deal of thanks to Jonathan Regenstein for today's presentation, and thanks to all of you as well. Have a great rest of your day, everyone.